In this episode we are in my recording studio, where I keep the computers that when I'm not making music, they're transformed into a designing and machining station. We're here because in this episode we will create a piece with my CNC machine using aluminum and copper. This process can be used to create pretty much anything, but today we're making a personalized version of the Springer bridge. Here is the original part. For those of you who like to know more about the CNC machine, I suggest you to watch the special I'll be publishing soon on the matter. I suggest it to all the people who would like to make their own pieces, or those who would like to just design parts to commission to a professional machinist. To know the machine, its capabilities and its limit, it's essential in designing a piece that is actually machinable. Here is the original HD part. Initially I thought I'd replace it with a piece of aluminum and copper, but I realized that this piece is incredibly hard, so it must be some kind of tempered steel which I'm not able to replicate. Since this piece is a structural part that influences directly the mechanics of the steering and consequently the safety of the driver, I've decided to build my piece around it. This will also give me a chance of demonstrating how to work the stock from two sides. Now, the stock is another very important thing to know before designing. In this case, I'll use two. One of them, it's a plate of aluminum 5mm thick, and the other one is a copper plate about 1mm thick. As you can see, I've already used this plate to make a few pieces for my Springer fork. We'll work the aluminum from both sides because the bottom part will have to fit the original piece, and the top one will have to have a pocket where we can insert our copper part with the logo design. So, let's get started. To be able to design the new part, we have to digitalize the original one. And to do so, I usually start by scanning the part and importing the picture into a CAD software, where I then can make the design out of polylines. Industrial and homemade products are both created having to respect the same mechanical and physics rules and limits. So I usually suppose that the engineer that designed this part followed the same thought process that I would have. So if I was him, I would have started by making the concentric circles that are tied to an existing geometry. So I start with the fork hole, and then using the center of this circle, I create the outside circular edge. Since most likely the shape is symmetrical, I'll copy what I've done already while pressing Shift to keep the polar alignment. Now I create a polyline, make it into an arc, and I select the middle point, approximately in the center of the shape, and I close it on a tangent to the other circle. Now, a second straight polyline will close the bottom of the design. Now, if we remove the original photo, we're left with a final design of the object we're trying to recreate. Once the original model has been created, I need to verify the dimensions by accurately measuring the original with a caliper and scaling the drawing to the size of the original part. Once I reach a satisfying level of accuracy, I usually print the piece and try to fit the original onto the paper version. Now that we have the original part as a reference, we can proceed with creating our own design. But first, I like to give myself some basic structures. First of all, I like to take care of what's needed to accurately flip the piece to work it on both sides. To do that, I place 2 holes on top and bottom of the vertical center of the design. Then, I like to leave some extra fitting room for the pass to simplify installation. So I'll do an offset of 0.3 millimeters around the original shape. Now, we can let the creativity run wild. I chose to give it this shape. This is the aluminum plate that will cover up the original piece and give us a structure to hold in place the copper insert. And this is the copper plate with the logo design on it. All we have left to do is to separate every design into different layers so it can be used to create the toolpath. Now let's print it and let's see what it looks like on the bike. Now is the time to verify if our paper model fits the bike. I've decided to use this shape also to complement another great piece of this bike, which is the headlight. So the point points to it. But anybody can choose the shape or logo that he prefers. It really is a matter of respecting the positions of the 2 holes for the bolts. In our case, the paper model fits. I really like what it looks like. Let's go back to the studio to machine it.